Okay, so algebraic proofs are the easy ones. Those ones you're just basically solving a problem on this side and you're giving me each reason why on the other side. That's why it's in logic, because you're using logic. You're trying to figure out logically why you're doing each step. So some of these are going to have a certain amount of steps. You may or may not know how many steps are in each one. So when you do a proof is always 100% of the time going to start with the given. So whatever you get for your given, that's what you're going to start with. So that would be your step one. So whatever you got for your given part, we're going to start it right here in your statements. These are our statements. So this is kind of, if it's algebraic like these, where you just get an equation, you're just working it out over here, telling me why on the reason side. Okay, so step one, that's just what's given. So you're just going to say given. Basically, that's the problem that you're given. And then over here, you're just going to work it out. So basically, what would you do to solve for x here? The next thing you would do is you would times both sides by 2. So you don't actually have to show your work over here, but this is what you're going to do to get step 2. So if I times by 2, these are gone. So I'm left with 4x and 6. And then 9 times 2 is going to give me 18. So you're just showing your steps. You do not have to show these times 2s over here. I'm just showing you what I'm doing. And then you have to say what you did. So what I did was I times both sides by 2. So this is multiplication property of equality. You can just put multiplication, that's fine. The whole thing, multiplication property of equality, is what technically should be written. Okay, next. The next thing you would do to solve is you would minus 6 from both sides. That's what you would do to get step 3. So you'd be left with 4x equals 12, okay? And then the reason, what we just did was we subtracted 6 from both sides. So this is the subtraction property of equality. Give me that t in there because there's substitution and there's subtraction. So if you put sub, you're going to lose some points. Okay, so I at least need, if you're going to be lazy, that's fine. Give me a 4th letter. Okay, that way I can know if it's substitution, it's SUBS. If it's subtraction, it's SUBT. Okay, next. The last step you'd probably do to solve for x is divide by 4. So right here, you're left with x, and 12 divided by 4 is 3. So what you did was we divided both sides by 4, so this would be the division property of equality. Okay, and that's what you want to get to. You want to get to the proof part. So you want to start with the given right there, and then the proof part, the x equals 3, that's what you want to get to. You always want that to be your last step. You will never, ever, ever use proof as a reason. Please don't do that. So many people do that. Never use prove as a reason. But the prove part will 100% of the time be your very last step on the statement side. Okay? All right, so maybe pause me. Try number 2. So I'm going to start 100% of the time with given. That's always going to be my first statement. Next step is basically you're just working your way to get the answer, just as x equals -2. So I'm just going to work my way down to get the answer. So in step 2, what you can do is just minus x from both sides. So if I minus x from 4x, it's going to give me 3x. And in this case, since both of them would be subtraction, you could actually do 2 steps in one because they're both subtraction. So that would be acceptable only in this case if they both are the same thing. Or you can just go ahead and do 2 steps. It doesn't matter either way to me. So that would be subtraction. And then step 3, you would subtract the 8 from both sides. So if it's the same reason, you can kind of do both in one step. Step 4 looks like this. So you don't have to write your steps. If it helps you, write them. I have no problem with that. But this is all you really need. And then what you did to get the x alone was you divided both sides by 3. So this would be the division property of equality. Okay, you got to where we were supposed to be. We got to the proof part. You're done. So a couple of properties that you may have forgotten or maybe didn't learn in Algebra 1, I don't know. So these 3 are kind of a little bit different. So reflexive property is just when something is equal to itself. So if it looks like this, AB equals AB, angle A equals angle A. So reflexive That's just basically equal to itself. Let me see if I can scoot that up a little bit. Okay, I always like to give you kind of the translation. Okay, it's exactly the same thing. Nothing switched, nothing looks different, it's identical. Okay, then symmetric is when you flip-flop something. So right here you have A, B, and C, D. Well, it flip-flopped. It turned into C, D, and A, B. So they just took them and switched them. Same thing over here, A equals B, and then they switched them, B equals A. So this is just when you, I'll just say flip-flop. Okay? And, excuse me, transitive. Transitive is always a big giveaway because there are always three things. So I've got A, B, C, D, E, F. There's three different things in there. So here's what they do. They tell you these two equal and then those two equal. And then what they do is they leave out the repeated part and you're left with A, B, and E, F. It's just like syllogism. So it's incredibly similar to the law of syllogism. Whatever's repeated, you leave it out. So over here, they gave you angles. 1 equals 2, 2 equals 3. Well, if you cross out the repeated, you're left with 1 equals 3. So it's almost the same thing as the law of syllogism. So transitive is when you leave out the repeated. Okay. And then down here, I have it real big down here because sometimes this is called the definition of congruency. So it just is basically changing from equal to congruent or vice versa. So vice versa just means you can go from congruent to equals. So it's just saying you can go the other way as well. So if you have something like this, the measure of angle A equals the measure of angle B. And then let's say in the proof part, the next thing you see is angle A is congruent to angle B. So what they do is they change, and this is the biggest giveaway to use this, is you're going to change it either from an equal sign to a congruent sign or a congruent sign to an equal sign. Basically, the reason we do that is this is talking about a number, the measure of angle A. So if it's a number, you want to use equals. This is talking about a picture, angle A. So they're talking about the angle, or if it's a segment, they want to talk about segments, they'll use congruent. So for a picture, you use congruent. For numbers or measurements, you use equals. So when you're doing a proof, if they switch it from equals to congruent or congruent to equal, this is your reasoning. So that would be the part that goes over here, definition of congruence or congruency. Some people say congruence. Okay, so these proofs are a little bit more difficult because they have to do with pictures. So in this, it's going to be the same idea, though. You still start with the given. This should say given, not if. So they'll want you to do the given part. So if I start here with the givens, I've got PQ and QS are congruent, the segments. And then you can put the other part in there too. So we've got QS and ST. So if they ever have more than one given statement, like this one has two, then you can just put them both in the same. Okay, and then you can mark them. So PQ is congruent to QS. And then they also say QS is congruent to ST. So all three of these are equal to each other. Here's all they're saying. They're just saying that the length of PQ is going to be equal to the length of ST. That's why there's no segment signs, because these are talking about lengths now. So the length of PQ is equal to the length of ST. So you have to figure out how to get there. That's going to be the proof part at the end. This one's not going to be that many steps. So what you have to do next is, if you notice they got PQ and ST. Well, if I want PQ and ST, then I got to get rid of the repeated part. So I can do that for my step 2. And then your reason, remember when I get rid of the repeated, what reason that is? That's the transitive property. Technically transitive of congruence, because if you have that congruent sign right there, it's going to be congruence. If it has an equal sign, transitive of equality. So depending on your sign, whether it's going to be congruence or equality, again, I'm not going to make a big deal of it. If you can give me this stuff, that's what I'm worried about. I'm not worried about little details. Okay, so we're almost there. It almost looks exactly the same, but I can switch it now. So it's almost the same thing. I'm just getting rid of the segment, and I'm getting rid of congruent and changing it to equals. Okay, and we just learned that one. If you change from congruent to equal, that's the definition of congruence. And then I can even let you use the shorthand. Instead of writing congruency, you can actually write the congruent sign. Okay, that's our full proof. So it's a little difficult because it's just blank over here and you have to fill it out. That's what makes them difficult. Okay, I got 2 more for you today. If you're brave, pause me and try it on your own. So I'm going to start with the givens for step 1. If there's more than one given, you are welcome to put them all in the same thing. So I'm putting both of those givens in the same one. So all they're telling me is M and N are parallel, and then P and Q are parallel. That's all they're giving me. They want you to show that 6 is going to be congruent to 12. So there are many different ways to do this particular problem, but you're going to have to use your angles. So let's find something, because we can't tell this group and this group are equal. So I can tell this group and this group are equal because I had these 2 parallel lines. Or I could have used this group and this group. It doesn't matter. So what I'm going to do is I'm going to match up 6 with an angle that matches up over here. So since 6 is on the inside, you can pick the alternate interior if you want. So 6 and 16, those are equal because I got parallel lines. That's what I'm going to do in step 2. And then you have to tell me why. The reason why I figured those out, those are alternate interior angles, okay? Technically, it's the alternate interior, not the converse, the other one that I can't think of right now, but alternate interior postulate, there it is. Okay, but again, I'm not picky on that as long as you know they're alternate interiors. That's what I'm worried about. So right now I'm at 16. And then the reason why I picked 16 is because 16 and 12, they have a relationship with each other. So they're also equal. The reason why I'm working my way to 12 is because I know I'm supposed to get to 12 somehow. Okay, that's what makes these difficult. So 16 and 12 are congruent. Why? Because they're corresponding angles. 12 is in the bottom left, 16 is in the bottom left. So if you have parallel lines, M and then that means all your corresponding angles are congruent. Okay? Now, for step 4, I'm trying to work my way to this. This is the end that I want to get to. So now I can say 6 and 12 are equal because I'm basically leaving out this repeated part. And why are 6 and 12 equal? We cross these out. When you cross out the repeated, that's the transitive property of congruence. Okay, so we made it to our end. That's all we had to do. There are a couple of different ways you could have done it. You could have used 6 and 14. Those are corresponding. And then you could have used 14 and 12 with the transitive property. You could have used anything up here that's equal to 6 and done it the same way. So there's a bunch of different ways to do these, but you just have to start with what's given, work your way to the end. Okay, so see if you can try this last one over here. You can do it like this and do all in one step like I did in this one. You can do it in 2 steps. It really doesn't matter. Makes no difference, just as long as you know both of those are given. Some people like to do them in separate steps so that you can kind of see the problem out a little bit easier. All right, so they gave me, let me erase this. They gave me angle 3. So we started here. And then they want you to prove that angle 6 is 133. Oh, no, this isn't the right picture. I must have left out the picture because that's not going to work. All right, so let's say M and N are parallel. I thought that went with the same picture. It did not. So let's say angle 3 over here and angle 6 is down here, because they're not going to be, in this picture, they're not going to be equal to each other. They're supplementary. They'd add up to 180. So this can't be the picture that goes with this. So I've got angle 3 here and angle 6 there. So it tells me that angle 3 is 133. That was given. Okay, so this one really only has one more step. So angle 3 and angle 6 can be congruent because they told me the lines are parallel. And since the lines are parallel, 3 and 6, these are alternate interiors. Okay, so I'm still not where I'm supposed to be. I'm supposed to get down to here. I'm supposed to say that 6 is equal to 133. Well, I can say that because we said that 3 was 133, and then we also said that the two were equal to each other. So in that case, we can say the measure of angle 6 is 133 degrees. The reason I'm going to ignore level 2 or step 2 right here is I'm going to take out the repeated. So I'm going to take out angle 3 right there, and I'm left with the measure of angle 6 equals 133. This is optional. You could either say it's the transitive property of equality, or what you could have said was we plugged in the 133 instead of the 3. So if you plugged in 133 right there instead of 3, that's actually substitution. Okay, so transitive or substitution, two different answers for the same thing. That's how that one works. Okay. All right, now for this last one here, please pause me and at least try. So at least get started. You should at least be able to get the given part. I know they're difficult and I know it's tough. So step 1, you can either do 1 step or 2 steps, doesn't matter. Step 1 is given. So they're just telling me that L and M are parallel and M and N are parallel. Okay, that's the given part. You're trying to make it to 1 and 12 being congruent to each other. Okay, so here's the tricky part with this one. You also have to establish that L and N are parallel if you're going to use any kind of angles between L and N. So this step should be this right here. Okay, couple of different options here. There's a proof that states that if two lines are parallel to the same line, so in other words, L is parallel to M and N is parallel to M. So if you have two different lines that are parallel to the same line, M, then they are parallel to each other. So you can kind of either state that in a really long way like I just did, or you can just pretend like you crossed out the repeated M, and so L is parallel to N. So you can call this transitive. Okay, so now if L and N are parallel, that means that 1 and 12 are equal. And the reason is because, now ignore this, 1 is on the top left and 12 is on the bottom right. These are outside. One's on the left, one's on the right. So those are alternate exteriors.